Today we're going to make a turntable for doing photography on, and I'm going to make it out of this. Other bits, need a bearing, there's going to be a base and a little screw that's going to go through this center of this bearing, but we're going to have that inside here. So I need to make a hub between the bearing and the plate. And because I don't have any stock that's big enough to do this, I'm going to make it out of this. So what we're going to do is we're just going to put our bearing in there. On the other end, the back plate, we're going to turn down this end to fit through the inside hole, and then we're just going to let the edge, this edge here, meet up against this tapered pulley surface here, like so. So that's going to be a fit for that. That's just going to rest. I'm probably going to turn this down as much as I can because I don't want this to stick up too much. I don't want the turntable decent amount off the ground, because then I can slip a cyclorama underneath the edge. So let's go down to the shed. Okay, so I'm just establishing a true surface here for the hub that's not tapered, and we are going to be able to grip in the through jaw when I turn it around the other way and do the reduced edge here. We'll do the bore and the bearing first while we've got it in this position, because it's quite easy to grip now. But first we have to get rid of a fair bit of this material. Bit of WD-40. Bad piece of aluminium underneath all that crap. Okay. Don't want to go too much further than that. Leave a little bit of room for that grub screw. Okay, I've just set up a boring bar to go in and do this bore. And the bore we need is, I think, 26 millimeters. Nope, miles out. We need 30, something around 30. I'll just clean this bore up first. So that's 16, I think it's probably, which is about 17 millimeters. Probably I only need to go another 3. Or about there. Pretty much there. This is not a precision fit. Just need to clear, just trying to clear the actual, yeah, which I have easily. So stop there. Now I've got to work out my proper depth. It's about 9, so I want to go in 9. So I'm going to touch off on the surface. Okay, I've touched off, so I'm setting the zeroing out my DRO for depth, and we're looking for a depth of 9 millimeters. This surface will line up roughly with the surface of the bottom of the back plate. So this will give us clearance of about 1 centimetre under the turntable. I was considering seating the bearing deeper, but in the end decided this would be fine. Our rough reading is 25.8. 25.86. Depending on what mood it's in. 25.86 at the most. 25.9. Check sound going, 27.6. We're getting close now, so switch to the telescoping gauges. Unfortunately, I don't have any outside mics above 25mm, so I just measured them with the calipers. This would be spot on for an interference fit, but I want a loose fit, so I'm going to go a little bit further with the skim pass. I cleaned up the back of the shoulder with a facing cut, then cut a bit of clearance for the inner race on the bearing. Now let's test that bearing fit. Beautiful. Sweet. I'm happy with that.
Time for a light chamfer just to break that edge.
So we have our bore for our bearing. Got a good hub to hold onto. We're going to turn it around now. Reverse the jaws out. So now we need to reduce this and probably put a true face here for indicating later on. Be a good time for a bit of a clean up. Turn this around and work on this surface here. We're going to reduce this diameter down to fit in the middle of our plate and get a reference surface of this that we can use later on if we need. Okay, so switch to the inside jaws. Let's see what we can get in terms of... And I'm rocking it back and forth as I tighten this.
After a quick visual inspection, the part's running true enough, so let's continue. The initial measurement of the plate showed 49.8mm is the bore size, so I'm going to target 50mm.
Still ways to go. 53.
Having reached our target diameter, it was time to test it with the plate. And that's when things started getting a bit weird. It didn't fit, so I gave it another 0.05mm and checked again. But it still didn't fit. Now I went around and around like this a few times. Probably too many times. What I hadn't noticed is that the bore was actually tapered. Now I realised this eventually, and this was still the right strategy for getting the fit that I wanted. But why on earth does the Lathe faceplate have a tapered bore? I have no idea. Anyway, we got there in the end.
There you go. That's what we want to see.
There was even a pleasant little surprise.
Didn't expect it to line up quite that perfectly.
Sometimes you just got to have a bit of faith in those machining gods.
I'm pretty happy with that.
Time to bring out the chamfering tool and break some of those edges. I want to clean up that front face a bit, so let's try a boring bar. It sounds a bit dramatic here, taking off those embossed letters, because we're taking an interrupted cut. Now that sounds much better. Not bad, but there's some paint around the outside I like to get rid of. Time for another chamfer, this time on the inside of the bore. I wasn't able to get all the paint, so let's see what we can do with a bit of sandpaper. That'll do nicely.
This is done. Got our ball throw bearing, and we've got our seat for the table itself.